Thanks, Samantha. Hi, everyone. Thank you again for joining. I recognize several of your names, so I'll just introduce myself again. My name is Lauren Gunn Sandell, and I'm a research scientist with the University of Colorado at the Anschutz Medical Campus. And Samantha and I work as biostatisticians in the department. And part of our job is being well versed in multiple statistical programming languages. So in my day to day, I currently use R for the most part. However, I have a strong background using SAS, and I still have projects that I work in SAS with. And I know it's fairly popular outside of the university at various health departments and various institutions. So hopefully you all learned something new today. I am going to share my screen now. Uh, Samantha, also, if you wouldn't mind, this is off the cuff, but maybe putting in the chat the link to the YouTube or the video where we download SAS Studio. I know it's the linked in the Dropbox, but that might be easier. So today I'm going to assume that you have some baseline understanding of SAS in general. However, in previous CU Data Week years, we have recorded sessions on how to work in SAS Studio, which is a cloud-based environment. Today, I'm working on the desktop. So we have a couple other recorded seminars, which will walk you through and orient you towards this interface, as well as how to download this local desktop version of SAS and make an account to set up the cloud version. So I'm just going to assume that those are familiar. If you have questions about it, we can talk about it at the end of today, or if you prefer, you can come to our office hours on Friday and we can do more. And I'm seeing a typo, so I'm going to fix that. Okay, so today I'm going to be talking about creating some flexible and dynamic SAS programs using both SAS arrays and SAS macro variables. At the end, there is a small section about SAS macro programs, which I don't think I will be able to get to in our short time today, but I did cover it a bit last year. And so you can refer to the recording last year and learn a bit more about that if you're not familiar with macro programs. So here on in this script is a link to CU Data Week. This is the same link where you have registered if you use the online version to register for this week. Within a week or two, all of the recordings of this year's programming will also be available at this link. So you'll be linked to the recordings which are hosted on YouTube and be able to watch those moving forward if you want to refer back to anything that we covered today or throughout the weeks. So just a little bit of introduction here. If you have a question, please feel free to add it to the chat, or you can unmute, raise your hand in Zoom, and Samantha or I will see that, and I would be happy to answer questions as we move through this script. So first, I'm going to touch on SAS arrays. So what is an array? An array is a temporary grouping of variables. And so in just general data speak, variables are typically the columns that we would have in a 2x2 type rectangular. And then the observations or records are the rows. So we are grouping columns, and this exists only during a data step of your SAS program. Within an array, we have elements. So you could have one element in an array, which means you really only have one column in your array. In that sense, I would say this is not a very useful tool to use. It becomes useful when you have a longer list of potential columns included in this grouping. One constraint that we have to abide by for arrays is that they have to be of the same class. So if you have a mixture of character and numeric variables in your data set, your arrays can only be of one type. So you could have one array that are for your numeric variables, and if you wanted to do anything with character variables, those would have to be in a separate array. So just the basic syntax here to specify use of arrays in our array statement within a data step. We have the word array, so we have to define it that way. This is not case sensitive, so you can have array in all caps or in lowercase. And then you create whatever array name you want. We don't want them to contain like special characters. We don't want periods or any of those. And there are some naming constraints as well. But usually you would maybe want to name it something that is an identifier for the types of columns that are in the array. Then we have within curly brackets a subscript. And so this is indicating the number of elements in this array. So you could have 2 elements in your array, in which case you would put a 2 here. You could have 100 elements in your array if you wanted, and so you would put a 100 there to indicate the length. And then we have this option, which is the element list, and that is an explicit call of these elements in your array. And I will be showing you examples as we move through the program. So the array name must be unique. It can't be based on a name of a variable you already have in your data set. So let's say you have a data set and one of your variables is SBP for systolic blood pressure. You then could not create an array with that exact same name. So your names can be up to 32 characters long, and you have to follow usual naming conventions, which means it can't start with a numeric. So it couldn't be numbered like 3 blood pressure. It would have to be blood pressure _3 if you needed to indicate for something like that. And then this subscript is, I already kind of walked through this, but it describes the number of elements in the array where we're using a number. We can also use a range. And then we have the special case where if we don't know or the number of elements could be changing, we have the option to use an asterisk. And this is a placeholder and is very flexible. So I'll show you an example of that later on. I always use curly brackets for arrays because for me, that's just the notation I learned. And it is distinct from some other syntax that you might use in a data step. You can also use the square brackets or regular parentheses. I tend not to use parentheses because that is pretty common in a bunch of other SAS statements. And so I like to keep it separate in my mind, but that is an option for you. So again, SAS arrays only exist during a data step. So if you're familiar with SAS, we also have other boundaries, which include procs or procedures. So arrays do not exist in those. They only exist during the data step, and they do not get carried forward. But anything that you create or manipulate in the array statement and subsequent elements of your data step are carried forward. And so that is where the power of using arrays is within. So let's walk forward. I am going to use one of the built-in data sets that's in the SAS help library. So in this desktop version of SAS, I can come over to my Explorer section and double click on libraries. And then there's this library called SAS help. And in here, there are numerous data sets of various sizes and topic areas. And so you can use these when you're practicing various coding steps in SAS. So I'm going to be using the baseball data set to begin with. So first, let's just take a look at what is in this data set so we understand as we move forward. So if I run a contents on here, what's going to pop up is, sorry, I got to move my Zoom controls out of the way. So we're getting an overview of what is in this data set. So we have 24 variables with 322 observations. And then if I scroll through and look at the variables in order that they exist in this data set, we can see that there is a mixture of both character and numeric variables. And so this is going to be important. Recall, an array has to include only one type of variable. So either numeric or character. So we have some team names of baseball teams, the names of the actual players, some statistics about baseball, some career metrics for the baseball players, I assume, and some other variables. So let's say we wanted to create an array with some of the baseball metrics. What we're going to do is we're going to specifically call that data set again, the baseball data set. And then I'm just going to be creating a temporary version of this data set that goes into the work library. And so looking at the syntax here, I have my array. So we have to have this start our statement in this data step. And then we have the name, the user-defined name that I've created for the array, which I'm calling BB stats for baseball stats. Then I have my subscript that is calling out the number of elements in my array. So I'm saying we have 5 elements in here. And I'm explicitly defining which columns I want in the array. So you will see here that I have N at bat, N runs, N hits, N home, and N RBI. These are 5 numeric columns that exist in my source data set. And we can see those up in this viewer pane here. So we're creating an array called BB stats, and I can run this. Nothing is happening underlying this data step because I'm not actually doing anything with this array. But I just wanted to show you the syntax here. So we'll run it. And you're going to see in the log that everything looks the same whether or not you created the array because nothing is happening yet. Also, I just wanted to say that when you're explicitly calling out the columns, they don't have to be in the same order that they exist in the data set. So I could have switched this around and put N runs first. I could have moved one to the end. It's going to do the exact same thing. What you do need to keep note of, though, is the indexing of these elements in your array is specific to the order in which you call them in the array. So in this case, my first element is N runs. And so if I'm indexing, N runs is equal to 1. I can move it back to where it was originally before, but now this index has changed. And that becomes important once we start using the elements in this array. So here we're going to pull out one of the elements. Apologies, it's a subscript. And we're going to actually use one of the elements now. So this is the exact same array that I had defined above, our 5 numeric elements in this baseball statistics array. And now what I want to do is create a new variable that is an exact copy for now of one of the elements. So here I'm going to create this new variable that I'm calling new_var. And I am calling specifically from the BB stats array element number 2. So if we go up to our array, BB stats, we can see that element number 2 here is the N runs column. So I would expect, based on this code, that I'm creating an exact copy of the N runs column. So we're going to check that. Right before I do that, though, I did want to point out that our case, or the name of our array is not case sensitive. So up here, I have defined it as being capital B, capital S for BB stats. But then I can reference it down here in all lowercase, and SAS knows this is the same thing. And this is unique because other coding languages are case sensitive if you're familiar with R or Python, for example. So that is a nice flexibility that SAS has. So I'm going to run this data step. And what we can see up here in the log is that there are still 322 observations in my data set. But now we have 25 variables. If you'll recall, when we originally looked at the contents, there were 24. So we have created a new variable in this step, and I'm going to show you that. So I'm going to print just the first 10 observations from my new output data set we've called BB, and I'm going to just show you the new var column and the n runs column. So we can see here that these 10 observations from this data set are in fact concordant. So these values are exactly the same. New var is an exact copy of n runs, which is what I would have expected. So this isn't really that useful now. Maybe you are wanting to create a new variable and you don't want to overwrite existing variables. So this might be an approach you take, though there are other options where you don't need to create an array. But I just wanted to exemplify how to create an array using the array statement, and then how you can call particular elements, right, using that subscript. So let's say you wanted to create an array that is all of the numeric variables in a data set, and you don't want to have to hand type out every single name that exists. Because if we look now, there's 24 variables in the source data set, and we can see the majority of those are numeric. And to be an efficient programmer, we don't want to have to type out every variable name. So what we can do is use the shortcut, which is using the underscore numeric underscore syntax option. And that's telling SAS that in this array, which is now 18 elements long, I am going to be wanting all of the numeric variables. So I would have had to know that there are 18 numeric variables. I could have counted them up here from the contents and put that as my superscript. And then instead of typing out all the names, just put this numeric. Again, I'm going to create a new variable based on one particular element in the array. This time I just chose element number 17. So we're going to take a look at what this is. Alrighty, so I am pulling out the first 10 observations. I have now all of the numeric variables included in my array. And if I scroll over to the right, we have this new var column that's been appended to the far right of our data set. And if we look back, we have a numeric variable here called log salary. It's not a copy of this one. I have this character variable here in the data set, obviously not a copy of that one, because we are only including the numeric variables in our array. But if we go one more variable over salary, we can see that new var is the copy of this element. So that is the 17th numeric variable included in this data set. So if we counted from the first column all the way through, we would have determined that salary was in fact the 17th numeric variable, and that was the one that we were making a copy of. So this is really nice because if you need to do data manipulation to a bunch of different variables, let's say you wanted to somehow, for some reason, convert all of your numeric variables to be character strings, this would be a really efficient approach because you could create your array and then you would create a new variable doing that data manipulation with some added indexing, which I'll show you momentarily, and be able to do that in far fewer steps rather than needing to type out every single one of those variables and manually changing it to be a character. So now I wanted to show you use of this flexible subscript option. So I mentioned before that the asterisk character specifies to SAS that the subscript needs to be automatically counted in SAS, and we're not defining a hard-coded number or count for this number of elements in the array. So this is really useful if you don't know the number of elements and you don't want to have to sit through and count how many numeric or character variables you're including in the array. This is also really helpful if you know that your source data is changing over time while working in the SAS program. And so you don't want to accidentally miss a particular column going forward. And so this is just a very flexible approach. I would say I use the asterisk for this flexible dimension indicator more often than not. If I have an array that's 10 or more columns, or I am working on data that's constantly changing, this is just a far easier approach, and you know that it's going to be flexible. So in this data step, I'm creating an array. Now, this is a new one called BB Career. I want to include a number of elements. I don't know how many there are, but what I want them to be is all of the variables that start with CR in the variable name. And this is a shortcut in SAS code syntax where if you start with a few digits or well, actually, no, sorry, it can only be characters because we're working off of variable names. But I'm saying I want to include all of the variables that start with CR. And then this colon is a placeholder. Any other characters that come up after the CR, I want to include those. It doesn't matter what is there. So let's roll back up to the contents log just to remind ourselves of what that looked like. So if I come down through the variable name column, I can see that now variable 10 starts with CR. So we have CR at bat. Then we have CR career hits, career home runs, career runs, etc. So we have a decent number of variables that start with CR. Let's just count it. 1, 2, 3, 4, 5, 6. So our asterisk, which is this superscript here, is really referring to 6 variables. And then I'm going to run this. So during the data step, if you'll recall, the array exists. After the data step is completed, this array doesn't exist anymore, but any new variables that we've created do. So I created a copy of that third element. I'm making copies only to show you that we can refer to certain elements in an array. But like I said before, this isn't really a common thing that you would need to do. Okay, so next I want to show you that you can include multiple arrays in a single data step. So you don't have to split out arrays into different data steps. So pulling off of arrays that we did in previous data steps above, I'm creating the BB stats one again, and I'm just going to include all of the numeric variables in this data set. And we're going to create a new variable that's numeric based on the 17th element. I also am going to be using my career array, and then I'm going to create this new career variable based on the first element of this array. So I will run that. I'm going to check the log. Again, we see that we still have the same number of observations, and now we've had 2 variables added to the full data set: size, which is what we had defined, and then let's just take a look at it. So if we scroll over to the right, we've had those 2 new variables added on to our output data set, this new variable that's numeric, which is a copy of the salary column, and then this new variable for career, which we had made a copy of the first career starting variable name, which was the career at bat, and we can see it's a copy here. I would usually say let's name this as a more descriptive variable name, but this is purely to show you that we are in fact adding the new variables from these arrays to the data set. If we wanted to know how many variables are in our array when we are defining this flexible count and just calling all of the numerics, we can. And so the way that we would do that is we're still using that same source data set. We only need to see one observation out of the data set to know the count of the array. And so what we're doing is creating this array or this new variable that we're going to call array count. And we are taking the number of dimensions from the BB stats array. So you might usually think, oh, this is usually if I'm doing some sort of function in SAS and then inserting an argument into that function, usually what you're using is the variable name. So a single column. But here we have this ability to count the number of dimensions in our total array, which is a collection of columns. And so now we're able to count how many numeric variables do I have in my data set, which is also the exact same number that are going to be in my array. So if I run this and then print that new variable, we can see that we have 18 numeric variables in our array. So that's really handy because now you can slowly start to understand that using these arrays can be really flexible and very functional when it comes to data manipulation. So this next section is going to cover how we actually create new variables. This is where I use arrays a lot. So I'm going to switch over to a different data set here. I want to use the class data set from the help library. So I'll run that and then we can take a look at what's in there. It's really tiny. We only have 5 variables here and there's only 19 observations in this data set. And we have information about a set of students who are in a class, their name, sex, age, height, and weight. So let's say for some reason I wanted to add some columns to this data set that describes all of the courses that they're registered in this semester. So if you'll recall, course does not exist in this data set yet. So let's say I have a separate data set from a different source, and I have columns that are called course 1, course 2, course 3, all the way up through 7 possible courses that they could be registered in this semester. And I want to bring it into my class data set. What I could do is create an array where I have an array that I'm calling course. There's 7 elements in this array. And then I want these variables to be called course 1 through course 7. So this is also a new approach that you haven't seen yet, where instead of explicitly calling out course 1, 2, 3, 4, 5, all the way through 7, I can create this vector of names. So course 1 through course 7. And SAS is smart enough to figure out, all right, I'm going to be filling in 2 through 6 between these bookended columns. So I'm going to run this data step. And then I'm going to print my new version of this data set. And what we're seeing now is our original 5 variables that we had in the source data set. And now we have 7 new columns that are all empty currently, but you can see that they were automatically created for every single observation in the data set. So immediately, through only 2 lines of code, really, we've created 7 columns, and they're all named in a way that I wanted them to be named. And actually, it was really only 1 line of code. So this is really cool. Now we can see that we have a lot of functionality added to how we're dealing with our data. So what we could also do is say, well, I don't want to actually have to write out course 1 through course 7. I'm a lazy programmer today. What we could also do is just say array course and its 7 elements, and SAS is going to say, all right, my new columns are going to be the array name with the index values added on. So we're going to have values 1 up to 7 because we're creating 7 new columns. So if we do that here and we print it, we can see that we get the exact same result as we did when we explicitly called out the first and last columns in this array. So that's really cool. We can also use other names to create these variables. It doesn't have to be a replica of what our array is called. So let's say we wanted to create a data set that had all of the months in a year. What I can do is create an array that I'm calling month. There's 12 elements in this array, and I want it to be the 3-character abbreviation name for the month. So January, February, all the way up through December. So what I can do is run this. I have a new data set, and now I've created a new data set that has all of those new columns, and they're empty because we haven't assigned any values to the observations yet. Again, let's say I'm a lazy programmer. what I can do is do an array, call it month again, and just use these bookended versions, January through December. SAS is smart enough to figure out what needs to be filled in the middle. So if I run and submit this code, we get the same result here. So it's really amazing how functional this becomes when we're wanting to add variables, manipulate variables, or do any other data management tasks. So really the power of arrays are in their partnership with what's called a do loop, because now we can loop through a bunch of columns and supply the same manipulation tactics to all of those columns. So I'm going to switch over to a data set that we'll just create using the data lines feature in SAS. So this is a small data set, 2 cities, and it is the high temps that have been recorded from January through December in each city. And these are recorded in Fahrenheit, which I've denoted with an F here. So I will run. We have created this data set. There's 2 rows with 13 variables, and we would expect that because that's what we've created here. If we print it, we can just take a quick look. We have Denver and Miami, and then their monthly highs, January through December. So let's say we wanted to convert the temperature values that are recorded right now in Fahrenheit to Celsius. The manual approach that we could do in a data step would be by creating a new variable. Let's say we call it Jan_C to denote that this is now recorded in Celsius. And then we could supply the function that converts this value for all of the January recordings into Celsius. And then you could copy and paste that 12 times. You just have to manually rename your new variables to be February_C, March_C, April_C, etc. So your data step would have 12 lines of code individually converting each month's values from Fahrenheit to Celsius. It's not a bad approach. It's not wrong, but we can be more efficient. So the way that we're going to do that is by using an array. So what we're doing is defining that array, which is our months. And so we can use this asterisk superscript here. We know, because we're all intelligent people, that there's 12 months in a year. But let's just remember that this is flexible. So if your data is changing, and let's say we were looking at months that also were unique to a particular year, maybe we have hundreds of months worth of data. And so we could put the asterisk here and call all of the possible months that we want. So this is the first step. We have to define our array. So now let's get into the do loop, which is where we're actually manipulating the columns in the array. So the way that we do that is we start with a do. This could be uppercase. You could also switch it to lowercase. It's going to do the exact same thing. And we want to do this for all of the elements in our array. So we're saying from index of 1 to the highest dimension in our array we've called month. So remember, this is not the name of the variable. This is the name of our array. So we want to include all of the columns in our array. Then within the do loop, we are going to define the manipulation that we're wanting to do. So what we're going to do is create a variable called month with this index value after it. So actually, excuse me, let me repeat that because I made a mistake. What we're doing is we're taking our array month and the indexed value. So index of 1 is January. So our new variable is going to be called January. And we're taking the existing value of January and then doing the conversion from Fahrenheit to Celsius. So what SAS is going to do is start at 1, and it's going to execute this for January. Then it's going to come back up here. We'll do it again. Now index is 2, do the conversion. Come back up, do indexes 3 for March, do the conversion. And it's going to loop all the way from January to the highest dimension in month, which is 12, which represents December. So now in just, well, really 4 lines of code, because we have the array, the do loop, our manipulation, and then end to signal it's the end of our loop, we are going to have revised all 12 variables. I'm also going to format here. This is an optional step just so that we have fewer decimal places in the conversion. So I'm going to run this and we're going to take a look at what our results are. Cool. So what we can see is we have the same city column and we have January through December. And we now have in place for every single city and month combination, the Celsius version of the temperature recorded that month. So hopefully you can see that this was far more efficient than having to do that manually for every single month. I also wanted to show you that at the very end, we have this new variable called I, and it has the value of 13. I kept this variable in here so that you could see SAS has indexed 1, 2, 3, 4, 5, 6, all the way up through December to 12. It then is looping back thinking, well, there's a 13th element. So this is where the indexing stops. And this is a variable that does carry forward. And in some cases, you might want to keep this. In our case, this means nothing to us. So what we would then do in our data step is just drop that variable, which is called I, as you'll remember, we called it up here. And so if I run this with that drop, that column is no longer in our output data set. And so that's usually what I would do. In some cases, you might want to keep the index if you want to see where it stopped, but usually I don't need to know that. I also wanted to say that a lot of the times we're not actually wanting to overwrite the values in our original data set into the source data set. So maybe you wanted to have columns that were called Jan and then a second column that's Jan_C. You can do that. And that is where arrays are really helpful. So, oops, I'm going to update this code and we're going to see if it works. Live coding is always scary. Oh, there was an error. What did I do wrong? Okay. Okay, that's right. Samantha, what am I doing wrong? We'll come back to this, but I wanted to show you guys that you can create new names. We're going to move on, but I know you can't. I'm just panicking live.
We all do it. I can't even do it either right now. I'm looking at this, I'm like, what are we doing wrong? But I can't.
Oh, you know what? It's because I need to create the new names up here.
Yeah, that's what I was gonna say. I
Yeah.
think the part is the array. You didn't. It's still just January to through
Yes. Okay. I will come back to this if we have time, everyone, or come to office hours because I know what I did wrong. We need to define 2 arrays, one of the existing values and then one that defines the new names for the new variables. Okay, so this is just the very beginning of what arrays can offer. There are so many functionalities of them going forward. I use them to manipulate time, date variables, because if you think about the information that we're getting in public health or clinical studies, there are so many variables that are of the same type that have similar problems, and we need to fix all of them at the same time. So this is where I'm using arrays most often. I did include 2 links here that you can refer to in your own time. One is a SAS support document, and so it's really nice. It walks you through SAS arrays and gives you many examples. And then I also included this UCLA website page that also talks about SAS arrays, and so this is really nice to refer to as well. So in the last 10 minutes, I'm going to cover some introductory material about SAS macros. So now we're completely shifting the frame of reference here. We're not working in arrays with lists of elements anymore. So we're going to put that to the side. So what are SAS macros? There are 2 categories of macros. The first category are macro variables, and then the second category are macro programs. I say this because people will throw around SAS macro and you don't know which one they're referring to. Usually, I would say they're referring to a macro program, which is a whole set of multiple data and proc steps, most likely. Macro variables are individual values of a variable. Both of these categories are processed using base SAS's macro facility. There's a lot of documentation about the capabilities with the macro facility, and so that is linked here in the SAS documentation. So I'm just going to create a macro variable right now. That is today's date, just to show you this example. So what is a macro variable? It is a single text value that is stored as a character string, even if that value is a number. And I'll show you in a moment what that looks like. So the way that we refer to these macro variables is by using an ampersand followed by that variable's name that you've defined. So I created this macro variable here that's called date. So if I wanted to refer to that later on in my SAS program, I would say and date. And so this date here is the exact same variable name that I have in my let statement. But in order to denote that this is the macro variable call, you put that ampersand in front. So you do this for all of the variables that you've defined. There's two types of macro variables. The first set are automatic variables that are created by SAS. These are with every instance, every time you open SAS, they already exist. Then there's the second set, which are user-defined macro variables. So that is what you or me are creating when we're making macro variables for our particular needs. Then the way that we view a macro variable is by using a put statement, and then it will be printed to the log. So I am going to pull this macro variable down over here so that we can show that. So first, let's take a look at the automatic macro variables that exist in SAS. And so the way that we're going to see the list is by using that %put call and then underscore automatic underscore. You could have written automatic in lowercase. Again, SAS is not case sensitive in this case. So we'll run this whole line of code, and then we'll look at the list here. And so the log now has printed all of the possible macro variables that you could use. It's a very long list, as you'll see. So most likely, you're not going to need all of these. As a programmer, there's really only a few that I find helpful. So the first set are related to dates. So we have system day, the system date, and then the system formatted using a date 9 format. So if I run all of this code, we'll look in the log and we see that it printed the system day is today, Tuesday, the 10th of February in 2026, and then formatted using the date 9 format that's built into SAS. So this is really helpful. Now, I also usually need to understand what the operating system is that I'm using and the version of SAS that I'm using. You would put that in the methods section of a research paper. And so these are the macro variables I use most often for that. So if we look in the log, we looked at I forget what this is called, the processing. So I'm using Windows, and then this is the version. And then for SAS specifically, we have the system version, which is 9.4. So you might be thinking, why is this useful to me right now? I will show you. So let's use our automatic variables. Oh, and also just to say, I had created my own date variable here called date. And if we wanted to look at it, we would say %put and then do the ampersand date. And then we can look at it. And so it just prints out right here for us. We don't need to create our own date variable because that's automatically one of the built-in SAS macro variables. and then you can choose any format that you want for it. So I would say you don't usually need to create your own date, but that was just to show you that you can. So now let's use these automatic variables. These are really helpful when you know that this value is going to be changing over time, and you don't want to have to manually change that every time you go into a SAS program, which is what we would be calling hard coding. So the date is commonly something that's changing because you're working on the project day after day. And so let's say we want to show a title that this table was printed on today's date. And so what we would be using is this macro variable created by SAS automatically, the system date formatted using the date 9. Then we're going to add a footnote to this table. We're going to say that this report was created using the SAS system version. So this is another macro variable. If you'll recall, we're putting the ampersand first to call that variable on, and then using the computer type with this particular operating system. So let's say Samantha and I were both working on this project, and she has a PC with a different operating system. When she would submit this code, it will be unique to her computer. And when I submit this code, it would be unique to my computer, but the script is exactly the same. So this is where it becomes dynamic and really flexible. So I'm going to run all of this code, and we're going to look at the output in the results viewer. So we have our title showing that this table was printed on the 10th of February using the date 9 format. And then at the bottom of the table, we can see that footnote, which now includes the numeric system version of SAS on my particular type of computer with this operating system. So with 3 different system macro variables in the footnote, and then 1 in the title, we've now completely, we have made this table be unique to today and my computer. So it's really cool. Hopefully you can see that this is going to be really useful as you develop code moving forward. So if we wanted to call within a title a macro variable, you're going to get an error if you use the single quotation marks. So I'm going to run this just to show you that. So if I run this and we look in the results viewer, the table title prints, but the actual value of this macro variable does not get printed. It's just the name of the macro variable, which is not helpful for us. So this is just a reminder that you would need to put double quotations around the title here. And so that's what we had done up in this first title and footnote. So I'm just going to create a whole set of different user-defined macro variables. And the way that we do that is by using a %let. So we are letting this new variable that I'm calling date, and then I'm going to create one called author, and then my favorite number, and I'm going to create these variables here. And then you put an equal sign, and then the value that you want it to have, followed by the semicolon, as with every SAS statement. So now let's check that the values of my user-defined macro variables are what we wanted. So I'm going to just check the author name. We can see that in the log, it gets printed author and then my name. And then let's also check my favorite number got assigned correctly. And if I check, I can see my favorite number, and it's the value of 8. So we're now getting the correct values being printed. If I wanted to see all of the user-defined variables, I can do that in one line of code using this underscore user underscore argument option. So if I run that, I can see all of my global variables that were created. So I have age break, author, date, favorite number, and female. And that matches these 5 variables that I created above. So now let's actually use the macro variable for something that's not just adding some descriptions in a title or footnote. So using that class data set, again, we had both boys and girls in the data, which are denoted as sex equals F for female or M for male. So if I run this, I could have selected using a where statement that I only want to keep the F for female in my data set. So when I print that out, I can see that in fact, using inference on names from the baby boom era, that these all look to be women or females. So what if I wanted to be more flexible? Let's say I have a variable where sometimes I'm going to be wanting to print only the females and sometimes I'm only want to be printing the males. We can use this macro variable in place of a hard-coded value, and I'm going to get the exact same result. Because if you'll recall, I defined this female value as a macro variable up above as F. So when I run this new print of the data set with this filtering capability, I'm getting the exact same result, which is really cool. Because if you'll imagine, what we could say is, well, what if this was a character or a categorical variable that had 15 different possible values? And one day I'm going to be wanting to look at one value, another day I'm going to want to look at a different value. Instead of having to hard code that value in quotes every time, you can just create this filtering variable and you just define that at the beginning of each session. So we could also use a numeric variable with a macro variable. So the age break macro variable I defined above is using the age of 15 years old. So now if I'm filtering my data, I should only get students whose age is less than 15. And so we can see here that in fact, all of my students in this class are less than 15 in this subset. If I wanted to say, well, what about I only want students who are under 12 years old? Instead of coming in and hard coding 12 here, I would only need to change this value of the macro variable. You can use the macro variables to create new names in your data set, which is really cool. So let's say I'm filtering only to the females in the class, and I want this new data set to be called F class to denote that these are only the females. I can use that macro variable up here to call that specifically. This is going to give me an error and I'm going to skip it for time because we have to show when the end of the macro variable is. And so we use a period to do that. So we're saying in the work library, I'm going to be creating this new data set where it's the value of my macro variable called female, period, followed by class. So if I run this code and I look in my work library, we have in fact created a new data set over here that's F class because the value of our macro variable was assigned as a capital F. So it's really cool. That way you could change this value here and automatically your output data set name would reflect this value of the macro variable. So the utility of macro variables is really to prevent multiple cutting and pasting of code and various steps in your code because you're only wanting to change maybe one or two values of a particular variable or filtering criterion. And so you can just define at the beginning of a data set that I want to be looking at countries. We're going to switch over to a new data set that's a demographics information. We're looking at school and poverty across the world. And so let's say today I want to look at only those countries who have poverty at 25%. I can create these two macro variables. One is going to be the output data set name, and the other is my poverty level. And then I can run this data step where I'm doing some manipulation, filtering to the poverty type. And if I look at the log, I've created a data set where there's 18 observations from the demographics data set, and my output data set is specific to the poverty level at 25%. But let's say, you know what, my investigator actually really wants to look at all the countries that were 50%. All I would need to do is change the values of these two macro variables to be 0.5 for the poverty level, and then the new name of my output data set. I run that new assignment for my macro variables, this data step stays exactly the same. So if I run that in my output data set now, I have created a new data set that's the POV at 50%. And there's only 7 observations in this data set now because we filtered to those with greater than 50%. And if I look in my work library, I have both of those output data sets still based on the individual criteria that were fed into this data step. So it becomes super flexible if you're doing reporting, if you are needing to change different input values and manipulate data from there. So I'm going to stop at this moment because there's only 2 minutes left in the hour. I hope that you learned something new today. If you have questions, please let me know. And if you wanted to learn what is in the rest of this program, diving into the macro program stuff, it's in last year's recording for the advanced SAS data management session. So thank you all for coming, and I can take any questions that you might have.
I think there was a mistake with the thing with the one I sent. I'm going to try
Mhm.
another one if somebody can try.
Oh, the survey link.
Yeah.
Okay. I can click on it and see what opens.
Yeah, that
Oh, yeah.
works, Samantha. Thank you.
Okay, sorry. I think I was copying. Oh, yeah, I see what I did. I did accidentally copy the wrong one. My bad.
All good.
Please do the second one I sent. And come to my session tomorrow.
Yes, we'll learn about red cap tomorrow, which is very exciting.